You guys have your test tomorrow for Unit 3. So today I'm going to go through the odd questions, so numbers 1, 3, 5, 7, etc. And then you can go back and do the evens. If you pay attention to this review, the test will be very, very easy for you. In fact, this is one of my favorite units. As long as you're paying attention, then you will do very, very well tomorrow. So we're going to start with number 1. And number 1, it says, what is the slope of the line that passes through the points 25, 5 and negative 40, 11? So what we need to know is that on your formula sheet, you would always have the equation. So the slope is my change in y's over my change in x's. So that means that it's y2 minus y1 over x2 minus x1. So to be able to use the slope formula, we need to first label our pieces of our coordinate pair. So this is x and this is y. Again, x comes first, y comes second. This ordered pair showed up first, so I'm going to give them 1s. These showed up second, so I give them 2s. So according to the label, y2 is the number 11. So y2 is 11. In the equation, there's a minus sign, so I'm going to write minus. y1 is the number 5. So the top, y2 minus y1 is done. So now on the bottom, I have x2. So x2 is a negative 40. Then I have a minus sign. x1 is the number 25. So now, go ahead and simplify 11 minus 5. You will get the number 6. And then on the bottom, negative 40 minus 25. A negative number with another makes a bigger negative, so that's the number negative 65. Okay, so we simplified, and that would be our slope. So in our slope, you could write it as a decimal by doing 6 divided by negative 65, but that would not be a very pretty number, so you can just leave your slope as 6 over negative 65, which is the same as negative 6 over 65. When there's a negative, you can just write it in the front. Very easy. So number 1, rate of change, y2 minus y1 over x2 minus x1. So in number 2, you're going to do the same thing. It says, what is the rate of change? But don't forget, rate of change means slope. Every time you see rate of change, it's the same as slope. So you are just using your slope formula for number 2. Label your points, plug them into the slope formula, and see what you get. Not too difficult. So let's take a minute and look at number 3. So in number 3, it says graph the line x equals 2. And then it asks, what is the slope of that line? So x equals 2 is not in the form of y equals mx plus b. So this whole chapter, we graphed lots of lines and we tried to get them into y equals mx plus b. But this equation does not have a y in it. So I can't use y equals mx plus b for number 3. So what we do when we have a letter and then equals a number is we find that axis. So in this one it says x equals. So here is the x-axis. And it says x equals 2, okay? Here is the x value of 2. What we need to do is draw a line that cuts through that ordered pair at the number 2. On this line, this point has an x value of 2. This point has an x value of 2. This point has an x value of 2. So if it's x equals, it cuts through the x-axis. It doesn't sit on the axis. It cuts through the x-axis at 2. So then the question is, what is the slope? So I jokingly said that when it looks like this, it looks like the side of a U. So if it looks like the side of a U, then my slope is called undefined. The slope is undefined. It drops straight down under, so it is undefined. So go ahead and try the same thing with number 4. So graph that line, x is 5, and then tell me what the slope is. Is it the side of a u, like the word undefined, or is it the top of a z for the word 0? Okay, let's take a look at number 5. So again, number 5, before we were graphing y equals mx plus b. And we'll get there soon, we're just not there yet in the review. So in this here, there's a y and there's an x. That's what gives me a slope in y-intercept. But in this equation, there's a y, but there's no x here. So we're not going to use the m and the b to graph this line. Again, it's a letter equals a number, so it's a special line. So I find my y-axis, here it is, and then I find the number -4. This is where y is -4. We cut through that axis at the number -4. Again, we have to cut through it. It can't sit on that axis. It has to cut through -4. On this line, this has a y value, 1, -4, 2, -4. All of these y values are -4 on this line. So now what is the slope? This slope looks like the top of a z. So this is a 0 slope. So the slope of this line is 0. It looks like the top of a z. So the slope is 0. Very easy. Go ahead and try the same thing with number 6. All right, 7. So number 7 is very, very important, but it's also extremely easy. So in number 7, it says, the graph of a function is shown on the grid. Write the ordered pair of the location of the y-intercept and the x-intercept. So easy. So a y-intercept lives on the y-axis. This blue line crosses the y-axis at the number -2. So to write that in an ordered pair, remember an ordered pair is x, comma, y. So the y-intercept, -2, has to sit in the y spot of the ordered pair. So -2 is going to be right here in the y spot of an ordered pair. An intercept means the other number is a 0. So my y-intercept is 0, comma, -2. Y-intercept, very important. Make sure the number is in the y spot of the ordered pair. So my x-intercept is where my graph touches the x-axis. Here's my function. It touches the x-axis right there. That x value is 1, 2, 3, 4. It's called an x-intercept. It touches the x-axis at the number +4. So be careful. Make sure you write that 4 in the x spot of the ordered pair. So x is 4 and the other number is 0. We wrote the y-intercept in the y spot of the ordered pair. X-intercept is where it crosses the x. Y-intercept is where it crosses the y. Very easy. How funny. So go ahead and try the same thing with number 8. X-intercept, y-intercept. Okay, number 9. Number 9 says, what is the y-intercept of the line graphed on the grid? So again, y-intercept, this is a terrible graph. I'm sorry, guys. So my y-intercept, not a good graph. Oof, not good. We're going to pretend that that line was right here. That's not good. What is the y-intercept of the line that is graphed on the grid? So here's my y-axis. My y-intercept, we said, sits in the y spot of the ordered pair. We're going to say, this graph is a little off, we're going to say that it crosses the y at 2. I know it's a little bit above 2. The one on your test will be on a perfect, exact little corner here. So my y-intercept, the y is 2. So I put the 2 in the y spot of the ordered pair. So this is 0, comma, 2. Number 10 is correct. So in number 10, what is the y-intercept of that graph? Be very careful that you put it in the y spot of the ordered pair. Y-intercept sits in the y spot of the ordered pair. Number 11. So in number 11, it says we need to graph. This is in slope intercept form. Whoopee, makes it so much easier. So slope intercept form means that it's y equals, y equals a number we call m, the letter x, plus b. So whenever it's in y equals mx plus b, I want you to write m equals b equals. M is the slope. It's the number attached to the x. This m is the number -3. B is the y-intercept. It's the constant without the x. It's the number 4. You could write that as an ordered pair, 0, comma, 4, because it's the y-intercept. So we always begin at the y value of 4. Always begin on your y-intercept. Y-intercept is a 4. M stands for move. It needs to be a fraction, so I put it over 1. -3 means we drop down 3. +1 means we go to the right. So from my beginning point, I drop 1, 2, 3 to the right 1. 1, 2, 3 over 1. 1, 2, 3 over 1, and continue that way. I connect my dots using a nice straight line. That is the equation, -3x plus 4. Go ahead and try the same thing for number 12. M equals, B equals. B stands for begin on the y-axis. M stands for move. If it's negative, we drop, and we go over 1. Page 3. All right, now we're in the fun stuff. Okay, number 13. What is the rate of change? Remember, rate of change is a fancy way of saying the word slope. The slope of the line, you just did it. The slope is the rise over run. So the slope is your change in y values over the change in x's. When you rise, you're rising up the y values. When you run, you're going down in the direction of the x-axis. So my slope is the change in y over the change in x. So when we did this lesson in this chapter, we said that you have 2 options. You can either pull 2 points off of this table and use the slope formula. Or you can tell me, what is the change of y's? So from a $9.25 money spent to $11, how much did it change? So to figure how much it changed, just do y2 minus y1. So 11 minus 9.25. And you are going to get the number 1.75. So that's the change in y's over the change in x. My change in x, it increased 1. So to write the equation, it says do the change in y over the change in x. So my change in y is the number 1.75. My change in x was a 1. 1.75 divided by 1 is just the number 1.75. The change in y over the change in x. Same as y2 minus y1 over x2 minus x1. Same thing with number 14. Number 15. What is the slope of 8x minus 5y equals 20? So you graphed these last week, and in order to graph, we said that we want to solve for y. The reason why we graphed by solving for y is because looking at this, I have no clue what the slope is. Remember, the slope comes from the equation y equals mx plus b. The slope is the m. But the slope will only be the number with the x when y is by itself. So what we do is we need to begin by getting y by itself. That's not the slope. That's not the slope. That's not the slope. So to get y by itself, then you'll see what the slope is. So to move everything out of the way, we start with the x. Minus 8x, minus 8x. That leaves me with a negative 5y equals. Do not combine this 20 and this x. They are not like terms. We can't put them together. I like to put the x first. It has a letter with it. We'll treat him like he's special. Negative 8x. I put that first. So it's a positive 20, so plus 20. Step 1, move the x to the other side. Step 2, get y by itself. To get y by itself, it means I need to get rid of this negative 5. He's in the way. Divide by negative 5. Divide by negative 5. That leaves me with y equals. If you're not good at simplifying fractions, in your calculator, just do negative 8 divided by negative 5. Or negative 8, control divide, negative 5. The calculator will say that it simplifies to a positive 8 over 5. A negative over a negative is a positive. We always keep slope as a fraction. Don't make that a decimal. 20 divided by negative 5, that's easy. That's the number minus 4. So that's the equation in slope-intercept form, but the question says, what is the slope? The slope is the number with the x. It's not the x, it's the number in front of x. So my answer is that the slope for number 15 is 8 over 5. That is the slope of the line. That is the rate of change. It would rise 8 and it would run 5. 16, same thing. Move the x. Divide the negative 7. (17). So in 17, we said that there is this equation called point-slope form. The reason why it's called point-slope form is because there's a point in here and there's a slope in front of that x. So in this equation, we said to graph it, we could solve for y, but we don't even have to solve for y in this one because we're not graphing it. So the equation that we said, it's y minus y1 equals m times x minus x1. That's what the original point-slope form formula is. The question is, what is the rate of change? Oh, rate of change. Rate of change means slope. Slope means m. In this equation, the m is always in front of the x. It's always sitting right here in front of these parentheses. So without even solving anything, I can tell you that the slope is the m, which is the number in front of the x. Don't even have to solve it. That slope, that rate of change, is the number negative 5. We could solve it. You could distribute and then move the 6 over, and you'd have a nice slope-intercept form. But all it's asking is the slope. The slope is the m. The m is in front of the x. So this had to be the slope. So number 18, same thing. What is the rate of change? What is the slope? What is the m in that equation? This will also be on your formula chart. So if it's asking for slope and you don't remember what meant what, the m would be on your formula chart, and m is always slope. This equation would exist on your formula chart, so you could see it. 19. Almost done. Easiest question of all time. You guys all better get this right on the test, which is literally the easiest question in the entire world. And it's on the STAR test every single year. So super easy. Pay attention and you'll do very well. What is the zero of the function? So these past 2 weeks, we've been saying a 0 is another word for an Xintercept. Your 0 is very simply your Xintercept. So if I look at this graph, here is my x-axis. Here is where the blue line crosses the x-axis. You don't even have to write it as an ordered pair. All I want to know is where it crosses. It crosses at the number -1. Where does your line cross the x-axis? A 0 is an Xintercept, which means it's where the line crosses the x. So easy, so easy. 20, same thing. Where is the 0 of that graph? Not difficult at all. Last 2 questions. You'll have plenty of time to get through this review before the end of class today. 21. What is the rate of change? Oh, rate of change. We know rate of change is slope. Rate of change is my slope. Slope is the rise over the run. It is the change on the y-axis over the change of the x-axis. So for this one, you have 2 ways that you can do it. I'm going to show you both ways. I'll show you the numerical way, in case you're a number person like I am. And then I'll show you the pictorial way, and you can pick which way you want to do it. So if we're doing this in the table, what I want is 2 perfect points. So I'll choose this one right here. That's the point x is 1, y is 1,000. Here's another point. The x value is a 2, and the y value is a 2,000. So I just pulled 2 points off of my graph. So we said slope is the change in y. How much did the y's change? From 1,000 to 2,000, they went up 1,000. Change in y over my change in x. A 1 to a 2, oh, that's easy. It increased by 1. So my slope is the change in y over my change in x, which is the number 1,000. Another way you could have done that is just by looking at the picture. From one perfect point to the next perfect point, it went up. It didn't go up 1. Yes, I know it's 1 block, but it didn't go up 1. It went from 1,000. Now it's at 2,000. So it went up 1,000. Then it went over. It was at 1. Now it's at 2. So it went over 1. Again, rise over run. Simplifies to a 1,000. So you can either use a table or you can use the picture. If you're using the picture, be very careful. Very, very careful to figure out what we have here. So now, because this is a word problem, I want you to add some words to this answer. So the slope is 1,000. That's great, but 1,000 what? So what it says is it's always the change in y over the change in x. So the y was talking about feet. So this thing is changing 1,000 feet. 1,000 feet. This here fraction, we're going to use the word per. So it's 1,000 feet per 1 was the x. The x was talking about minutes. So the slope is that this graph is changing 1,000 feet per minute. I found the number, that's the most important part, by doing the change in y over the change in x. So 1,000 over 1. So I'm writing that as 1,000. The change in y was talking about feet. 1,000 feet per. The change in x was 1 minute per 1 minute. So this guy is increasing 1,000 feet per minute. You can try the same with number 2. If you like the numerical way to make for sure that you're counting correctly, here is a perfect point. The x is 5, the y is 2. Here's another perfect point. The x is 10, the y is 4. Slope, change in y. How much did your y's change? Over change in x. How much did your x's change? You will get a fraction. Let it be a fraction. That's fine. Fractions are perfectly fine in this chapter. So you'll write that fraction, and then you'll write bottles, because that was the change in y, per minute. So they're packaging shampoo bottles, something bottles per something minutes. You can leave it as a fraction. Very easy. Rate of change, slope, change in y over your change in x. Last ones, 23 and 24. All right, 23. It says, what does the x-intercept represent? So we didn't really go through this a whole lot in the chapter, but it's common sense. It's not that difficult. So it says here, the x-intercept. What does the x-intercept represent? So x-intercept happens on the x-axis. It's not this. That's not the x-intercept. It's not this. That is not the x-intercept. So they're trying to mess you up. They do that all the time on a STAR test, where they'll give you these random numbers that don't matter. I don't care about these. I want the x-intercept. My line crosses the x-axis right here at the number 6. So I'm going to write this one as an ordered pair. So my x-intercept is 6, 0. So that's great. I found it. I know what the x-intercept is. But the question is, what does it represent? So that means, what are the words that goes with this here? So this 6 was talking about time. More specifically, it was time in hours. So it takes 6 hours to get 0 inches. So what this means, it says the tank water level is dropping. So it drops, and it takes 6 hours for it to have 0 inches. If it has 0 inches, it means it's empty. So it takes 6 hours for this thing to become empty. 6 hours until my tank hits a height of 0 inches. So 6 hours until it's empty. So try the same thing with number 24, your x-intercept. What was it talking about? It takes 20 blank for what to happen? 20 blank for our fuel. So write it as an ordered pair. Write down what it was talking about, and then make it make sense. It takes 6 hours for this tank to become empty. 0 inches means it's empty. Not too bad. Okay? So if you are good at these 24 questions, you will do extremely well on your test tomorrow. Make sure that you look through each of these questions again before you take it. Specifically, make sure you know how to use your slope formula, make sure how to graph lines, and identify key attributes like x-intercepts and zeros. Not too difficult at all. Good luck on your test tomorrow. I hope you all do very well. If you made it all the way to the end, in the comments, just for fun, so if you made it to the end, in the comments, go ahead and solve this old question for me. There you go. So just as a flashback, just for fun, for all of you wonderful people that made it to the end, go ahead and solve this question on a piece of paper. Write the answer in the comments, and then I know where you all are all the time. I mean, I know what classes you are in. So if you solve it correctly, you put it in the comments, then I will give you, I'll bring you something nice if you do that correctly. Okay, good luck on your test tomorrow. Adios.